Okay, everyone. Our next guest is Victor Lage. His lecture title is Learning Languages and the Brain. So he's going to talk about the effects of learning on mental health. Victor has been learning both English and French since his childhood. He's had a dream of becoming an ambassador, but he ended up becoming a clinical pathologist, and he worked at SATA Hospital for 25 years. He is a member of the International Association of Hyper-Polyglots and speaks Portuguese, English, French, Spanish, German, Dutch, and Russian. He completed a master's degree on evidence-based healthcare, and right now he is pursuing a master's in translation. So welcome, Victor. The floor is yours. You have 20 minutes.
And read. I hope you are seeing it now. Are you seeing it?
Yes.
I think it's so. So when I get to know the Poliglotar, I was very excited because I just love languages, as you already have known. And I have something that I've been studying about brain and languages, which I would like to share to you. Any problem? So I'll start with that quote from Ray Bradbury, which was one of the authors that gave me the pleasure to learn English. My slides are very big, and I don't wish to tell everything, speak everything. Just a guide. I will tell you about the science behind languages and brain, just a little of it. This is a presentation plan. I reserved to the end a little bit of a personal story, and I will guide you through all those steps about how the language processes brain, how the brain processes the language, and how it's a good idea to learn a language. So, I just step something. Okay. This is my conflicts of interest since it's a scientific presentation. It's just a quick presentation because all those factors can be interference in my thought about the subjects. Particularly, I am a polyglot and I love it, so everything I will say about you is about languages is good. I won't say the bad steps. And I worked in a rehabilitation facility for 30 years, including a neurorehabilitation facility. So that's why I learned about that. And it's already been said, I studied evidence. This is not for you to know everything. This is just to give you a notion. An RCT is a so-called random controlled trial. This is a kind of evidence where you put, for instance, for a COVID vaccine, half the people are subjects and half the people are subject to a placebo, and then you at the end of the study analyze who develop immunity and who don't develop immunity. This is not possible in languages. So we are speaking of evidence, but we can't say it's a smoking gun. However, it's very strong evidence what we are going to tell. I would like to start with a notebook. I love science fiction. In 1948, George Orwell wrote the book The Big Brother, 1984, where he proposed that the party, which was the political center of the country, the political direction of country, proposed the generation of Newspeak. Newspeak was the new language, and each year Newspeak would be renewed with less words. That would mean less capacity, less ability of the people to think against the regime, controlling the thoughts through speak. Is it possible? Fortunately not, because soon the people would develop slang, like doubly plus ungood for a very, very bad thing that the words had been banished. So it's not possible to banish thoughts by banishing words. But would it be possible to do the reverse? Let's start with the research from Wilder Penfield at the years of 1800 to 1900. This researcher would like to know if the mind can be explained by brain function. And he would do research in patients of epilepsy, in which there were done open neurosurgery, and he would stimulate the brain with a very, very mild electrical current. And the people will feel smells, will remember scenes of the past, etc. With that research, he and other researchers were able to develop what is called the mapping of the brain. For instance, so we have this drawing here, which is the mapping of the brain's sensitive areas. You can see that, for instance, the hand has a bigger representation than the feet or the rest of the brain. Well, after that, the further research, people would research, the researcher would make analysis about patients with aphasia. They discovered that the language is controlled by basically three specific areas of the brain, which is Broca's area from Broca, a French physician, French researcher, where is the control of the written word. Geschwind's area from a German researcher, which is a rewiring area between Broca's area and Wernicke's area, which is for spoken and hearing language. If a patient had a specific lesion in a specific area of the brain, that resulted in a specific deficit of speak or writing or both. But the patients were normally intellectually, they just couldn't speak or write or read. So this way, it was determined that the brain has some specificity as to areas of control. So here I put the map of the brain of the language so that you can more or less understand what comes into play when we learn and exercise speak. We need many parts of the brain, because we have the primary visual cortex. Without the visual cortex, we won't read. We have those three areas, Broca's, Wernicke's, and Geschwind's. And we have the primary motor cortex to make your mouth move, the primary somatosensory cortex to make we feel what are speaking and talking or writing. And to coordinate that, we need the frontal part of the brain, which is planning. So when you learn a new language or when you learn a new musical instrument, you have to coordinate all the areas that I painted in this drawing. Let's speak about something different. People say,
Victor, you have about 10 minutes.
okay, this is
Most.
neuroplasticity from this author. He said that new neurons don't form, but synapses or connections form. And it happens in kids, and it happens also in adults. In adults, this green part, the corpus callosum, is very important, and the area for language and music training is very important too. Here is a study made in Brazil about illiterate people. Those people were subject to language training, and you can see from left to right that the flow of the brain, which is painted red, blue, was enhanced in all areas of brain. Many animal studies confirmed those findings, and also studies confirmed that at first, polyglots' brains are not different from any normal brain, but they become different because some areas became enhanced. Other studies have confirmed that in average, uh, training in a language means about 4-year protection toward dementias, toward the developing of dementias, and that the blood flow enhances all of the brain. And ongoing studies now are connecting color perception, language, and mathematics. For instance, Oriental people are thought to be learn better mathematics because of the structure of the language. These are ongoing studies. And also there are ongoing studies connecting the limbic systems and the emotions. How do words evoke emotions, and how do that influence people who use the languages, who understand the languages? This drawing here just shows the limbic systems, which is very near to other systems which are enhanced with language. Those research are ongoing, they don't have solid results. So that is last, I would like to tell you a little personal story about mercury and calomel. Calomel, this beautiful crystal, is a crystal made of mercury, and it gave me a personal lesson. Uh, to be summary, we won't tell about all the structure. Calomel is used in electrodes to measure pH and sodium and potassium in chemical analysis. All of them have the calomel electrode as a standard to which the electricity of the atom we try to measure in a solution is compared. So we had just received this analyzer here, which is a blood electrode, and it has inside of it a calomel electrode. So that one day, the machine has just reached our laboratory, and we needed to give a patient's result, and the patient was waiting. But the analyzer wouldn't give correct results. So people asked me, Dr. Victor, please read the manual. The manual wasn't available in Portuguese. And the electrode was one of these little things in the center. So I read the electrode, and I came to conclusion that the manual asked us to replace the calomel electrode. So I said, we have to replace the calomel electrode. And people asked, this is very expensive. We can't do that. The analyzer has just reached our laboratory. That's what said the manual. And the patient is there. Then they answered me, we don't have an electrode to replace. So I reread the manual, and what I did was to replace the calomel electrode. I took it, I cleaned it, and I placed it again. That's just a word play. I never knew if it was really what was meant at that time, because the machine had been shaken during the transportation. And the manual was from Copenhagen. The original manual, I hadn't access to the original manual. So this, I bring this little story just to tell the people that sometimes a little word can mean many things. So, thank you. I will try to stop sharing now.
Okay, thank you so much for your presentation,
Hope you
Victor.
enjoyed.
I'd like to ask the audience if anyone has questions. You're able to either speak through your mic or leave questions here in the chat box. We have about 7 minutes. Oh, a gente tem uma pergunta aqui em português da André Albuquerque. Respondemos 2 minutinhos, Vitor, para falar sobre o FOXP12 e como o gene FOXP12 afeta as capacidades linguísticas.
Unfortunately, I have no specific knowledge about FOXP2 genetics. I'm not a geneticist. I have never studied this specific gene.
Anyone else?
Can I go next?
Yeah, sure, Josie. Go ahead.
Yeah, my question is about the areas of the brain in language. For example, Broca's area and Wernicke's area. Do you know if there's like any possibility of those areas being connected to other areas in language? For instance, in Italian, we automatically use gestures to express ourselves better. And is there any connection like between the area of the brain, like Broca's area, and a motor area?
That's the point of it. Language is a complex activity. It has been isolated that you have a writing aphasia if you have a lesion in Broca's area, and you have a speech aphasia if you have a lesion in Wernicke's area of the brain. These are general rules for not every brain is equal to one another, but it works for most people. That means that if you lose some of specifically that part, you will lose specifically that function. But for instance, the gesturing are activities that are involved the anterior and posterior gyrus of the brain. They cross about halfway in your brain, and one is for motor areas, and the one is for sensitive areas. So that if I am, for instance, raising my hand now, I'm using that area of the brain and not necessarily the areas of language. For instance, if I use hand signal language in any language, I will be using one of the areas of language. For hand language, it hasn't been specified that I know. but we also use the motor areas. When you read or when you speak, you use the motor areas in the mouth to formulate words, and you use the sensitive areas to know where your mouth is. So you have to integrate the areas of the language, those areas that are needed for language, with the areas of movement and sensation. And to read, you have to integrate the areas of visual sensation, which is the parts of the cortex behind of you. So it happens that using a language or using an instrument is an activity that involves multiple areas of the brains. And as you exercise music instrument, as you exercise a second language, your brain generates a higher number of connections, and these areas are enhanced. But also, if you do that continuously, it results as a brain training, and the blood flow will reach every part of the brain. And so, for instance, for Alzheimer's disease is associated with a protein called the tau protein. If you have a better blood flow, you get rid of the bad tau protein with more efficacy. So that's one of the hypotheses that leads to think that having a better blood flow and training your brain will delay the onset of some dementias.
Okay,
But
so we have more
if you lose the part of the brain which is responsible for the movement, no matter if you have a good language area, you won't speak. In Italian, at least, we will speak, but we will not gesture.
Okay, I have a question from Jerubala here now. We have 7 minutes at most until the session is over. So he has a couple of questions, actually. Do you think hypotheses like Sapir-Whorf have any basis? And do you think other humanoids like Neanderthal had developed languages, and if species from other branches like dolphins are developing other brain structures for language functions like ours?
It is said that dolphins, I don't know of animal research at that level, but it's said that dolphins are able to develop language, not language as we know it, but it's a sound language. And they have shown behavior which is associated with upper function of the brain. It's not unknown that the dolphins save men in the sea from drowning. Some decades ago, some research was made with apes, and they were able to develop a very simple linguistics. They didn't have the phonetic, the mouths didn't allow them to speak, but they could communicate and understand and follow simple commands and ask simple things through hand language. But it was never really determined if it was the kind of language we humans develop. I don't know. This is an old research, and I don't know why they had stopped in that. But some of these apes were used in space rockets. They were used as subjects. But I don't know, they stopped that research, possibly due to animal rights opponents.
Okay, so there is one of our interpreters here and lecturers who'd like to make a comment. Marcia? Oh, she's in the booth. I don't think she'll be able to.
Somebody says here recursivity. Animals doesn't have domain of that. That's probable because it's the domain of build a complex language perhaps is beyond their brains. You can train a dog, so that's perhaps why they stopped that research, because you can train a dog, you can train even a cat, perhaps you can train a monkey to do that. And that's not language.
Okay, just 1 second. Masi would like to speak, but I think only Julian can get it out of the interpretation booth. So let's hope he sees my message here. Just 1 second. I don't know if anyone else would like to ask or a question or make a comment.
Somebody is asking about Neanderthals. That I know, nobody has proved that humanoids before Homo sapiens were capable of true language. Perhaps that's the gap between human and other primates. I don't know. This anthropology. I think that. Someone gave a link to something about the
all right, yeah. We also have a question here from Marcia, one of our interpreters and speakers, and she asks you to explain a little bit better of what you're saying, like on slide 9, like neurons don't form, but new synapses do.
The fact is, our brain solidifies the knowledge through synapses. Actual science hasn't reached exactly how, but you have, as we train in a language or as you train in an ability, new synapses are done. And that means the flexibility to have, like that, if that is a neuron, that is another. The synapses are prolongings of the bodies of the language that connect with each other. And some of the knowledge, according to nowadays research, would be fixed in synapses. And other synapses would be responsible for the enhanced flexibility of learning new things. And so at the moment, the process of learning, you have to generate synapses around the brain, new synapses. And some of them will mean new knowledge, new memories.
Serão novas memórias, novas lembranças. Novas lembranças, novas memórias.
Okay, it sounds like the interpreters are out of the booth. Márcia, if you're still there, you have the floor now. You can speak.
Alô?
Márcia, pode falar agora. Consegue me ouvir? Yeah. Can you listen to me?
Alô? Posso falar?
Prontinho, Márcia, tá, you're on. Sim,
Okay.
já tá.
Should I speak in English or I can
Eu
explain
deveria falar em
Portuguese?
inglês ou explicar em português?
Não, tanto faz agora, tanto faz.
Tanto faz.
Okay?
Doesn't
Doesn't
matter.
matter.
Eu vou falar
Estou ouvindo duas vozes.
Eu vou falar rapidinho em português. Obrigada, Victor, pela palestra. Achei muito interessante. Como eu falei ontem, a minha palestra não vai ser tão técnica como a do Victor, ele que é o especialista. E amanhã, para o pessoal não pensar assim, que já assisti a palestra do Victor, não preciso assistir a palestra da Márcia, porque vai falar de neuroscience. Amanhã a palestra vai ser mais prática, vai ser como usar esse conhecimento que o Victor mostrou aqui hoje na prática para aprender o idioma, entendeu, gente? Então, não precisam pensar que eu vou passar pelo cérebro de novo e explicar esses estudos. A gente vai mais falar como que a gente pode fazer para ativar o nosso cérebro na prática, para aprender, tá bom?
Excelente. A minha palestra eu não sabia, mas, vamos dizer assim, complementa a sua, né? Quando eu propus a palestra para Juliano, foi justamente porque, do ponto de vista neurológico, eu não tenho tanto conhecimento genético, técnico de tudo, eu sou aprendiz da coisa ainda, mas desde aquele primeiro estudo que foi feito no meu hospital com pacientes que não sabiam escrever, e ela foi a nossa pesquisadora, ela pegou o cérebro, fez ressonância nuclear e foi ensinando as pessoas, e à medida que ela foi ensinando, havia mais fluxo nas áreas do cérebro. Isso me fascinou e desde então eu vivo procurando evidências sobre isso, porque eu adoro línguas, né? E as pessoas falam que a língua é um brain training, que um instrumento musical é um brain training, e praticamente eu venho fundamentando isso aí do ponto de vista metodológico. Então, como vocês iam falar com linguistas, eu falei, Juliano, deixa eu falar um pouquinho, porque as pessoas vão gostar, porque todo mundo gosta de língua, vai ter mais uma razão para falar, era essa a intenção.
E você
Eu não queria ser muito
não,
técnico.
né? Você fala muito.
Muito bem.
Falar aqui. A gente tem que terminar, porque daqui a 7 minutos a gente está começando outra palestra nessa, assim, não é nessa sala, mas é com essa mesma conta do Zoom. Então,
Não, Juliana, eu já estava esperando só ele finalizar, eu já iria interrompê-lo para poder passar aqui para a parte de agradecimento dos nossos patrocinadores, tá bom, pessoal? Obrigado por terem assistido essa sessão aí dupla de palestras, tá bom? Então, agradecemos a todos e esperamos vocês aí nas próximas palestras aí até o final do dia. Só conferir a agenda. A gente vai continuar a ter palestras simultâneas a partir de agora, tá bom? Então, nos vemos
agora
aí
a gente vai ter uma palestra que não é simultânea, é só da Mariolaine, mas depois vai ter outras que são simultâneas, tá? Então é isso.
Certinho. Obrigado aí pela retificação, Juliana. Então, até breve, até logo.
Até daqui a 5 minutos. Tchau.
Obrigado a todos pela paciência de ouvir aqui as minhas tecnicalidades.
O pessoal te ouviu, mas também ouviu os intérpretes aí. Márcia, como é que foi essa experiência aí, simultânea?
Foi bem interessante. Tinha muito termo técnico que eu não estou acostumada a usar no dia a dia. Então, eu tive que fazer aqueles parafraseamentos que você falou no outro dia.
Explicar o que era em uma palavra, explicou com 10, né? Mais ou menos.
Tipo isso. Ou o contrário, né? Peguei 10 e fiquei com 2.
Então foi bem movimentado, até porque a Márcia está num trailer aí. Então é uma interpretação remota e interpretação remota em todo sentido aí.
É uma loucura.
Quem está dirigindo esse negócio aí, ninguém sabe. Tá, pessoal. Então, até mais, viu?
Até daqui a pouquinho, gente. Até logo. Tchau, tchau.
Até mais.